Hello students, welcome back to the video lecture series of numerical methods in chemical engineering. I am Dinesh Mehbubani, HOD in chemical engineering department at LJIET Institute of Engineering and Technology. Today we are going to start a new chapter. The name of the chapter is numerical differentiation and integration. Till now in this subject we have completed 4 chapters. Chapter number 1, that was approximations and errors. Chapter number 2, the name of the chapter was solution of algebraic and transcendental equations. Then we studied chapter number 4, that was curve fitting, and then after we studied about finite differences and interpolation. Okay, numerical differentiation is the extension of interpolation. So it is advisable to prepare this topic after interpolation. Okay, so if we recall the interpolation, what is the meaning of interpolation? Interpolation is the process to find the value of y for the intermediate value of x from the given set of tabular values of the function. Okay, then there are basically 2 types of interpolation: interpolation with equal intervals and interpolation with unequal intervals. Which methods are included in the equal interval interpolation? Newton's forward as well as Newton's backward, while Lagrange's interpolation and Newton's divided difference interpolation are the methods of unequal interval interpolation. Okay, see what is the basic difference in the normal differentiation and the numerical differentiation. In normal differentiation, it was compulsory that the function should be continuous. The function should be continuous, but here we can find the differentiation of the discrete function also. So this is the basic difference between the normal differentiation and the numerical differentiation. Okay, let us first of all define the numerical differentiation. It is the process of calculating the value of the derivative from the given set of data values. Now the given set of data values will be x0, x1, x2, x3 and so on, and for that corresponding values of y will be y0, y1, y2, y3 and so on, and y is equal to f of x function will be given. Now we have to find the derivative of the given function at different values of x, and that values of x can be tabular as well as non-tabular. Now what is the meaning of tabular? The values of x that are given in the table are known as tabular values, and the values of x that are not given in the table are known as non-tabular. So for all values we can find the derivative. Okay, see which is the best way to find the derivative. The best way to find the derivative is to first of all find the interpolating polynomial. See, if you remember, we were finding the interpolating polynomial with the help of Newton's forward, Newton's backward. So first of all we have to find the interpolating polynomial and then take derivative. And if you want to find more derivative, higher order derivative, then also it is possible. Okay, we can take derivative of the given interpolating polynomial. Like if f of x is given, we can find f dash of x, we can find f double dash of x from that. Okay. So in this way we can find the numerical differentiation. Okay, let us derive the formula of numerical differentiation. See, there are again 2 types for this: equal intervals and unequal intervals. For equal intervals we are having 2 methods: Newton's forward interpolation and Newton's backward interpolation. Similarly for unequal we are having 2 methods: Lagrange's and Newton's divided difference. See, for unequal intervals, remember, for unequal intervals we have to use the formula for interpolating polynomial. First of all find f of x, then take derivative, then again take derivative if it is required. Okay, then place the value of x in that particular polynomial. Okay, but for equal intervals we have to derive the numerical differentiation formula. So let us consider the Newton's forward interpolation formula that we have already derived in the previous session. Okay, see, if we write the Newton's forward interpolation formula, then it can be written like this: y0 plus p del y0 plus p into p minus 1 upon 2 factorial del square y0 plus p into p minus 1 into p minus 2 upon 3 factorial del cube y0 and so on. Okay, we can also write like this. Let us simplify this. Y0 plus p del y0 plus p square minus p upon 2. Okay, then p in bracket p square minus 3p plus 2 upon 6 into del cube y0 and so on. Okay, see, if we simplify this term can be written as p cube minus 3p square plus 2p. So let me write that p cube minus 3p square plus 2p. Okay, now we have to take the derivative of this. So it is a function of p. So first of all we have to take derivative with respect to p. Now what is the value of p here? P can be written as x minus x0 upon h. So if I want to find dy by dx, how I can find dy by dx? See, dy by dx can be found by dy by dt into dp by dx. Okay, because p is a function of x and y is a function of p. From this, what will be the value of dp by dx? See, dp by dx, here x0 is any value, so the constant will be, derivative of constant will be 0, derivative of x will be 1, so dp by dx will be 1 upon h. So I can write here 1 upon h into derivative of y with respect to p. So if I will find dy by dp, what will be the dy by dp? Okay, see, here I can write, if I am taking derivative of y0, the derivative of y0 will be 0, then derivative of del y0 into p with respect to p will be del y0. Okay, then here taking the derivative I can write 2p minus 1 upon 2 into del square y0 plus derivative of this term 3p square minus 6p plus 2 upon 6 into del cube y0 and so on. Okay, this is the formula for dy by dx. Okay, now if I want to find the formula for dy by dx at x is equal to x0. See, if I am taking x is equal to x0 here, so what will be my p? My p will be 0. Okay, my p will be 0. So rewriting the equation, it can be written as 1 upon h into del y0 plus p is 0. Okay, so I can write here minus del square y0 by 2. Okay, here these two terms will be 0, 2 by 6 is 1 by 3 plus one by 3 into del cube y0 minus del raised to 4 y0 by 4 and so on. So this is the formula to find dy by dx at x is equal to x0. See, you can see 1 upon h, then del y0, see, we are taking the differences, first order difference, second order difference, third order difference and so on, and the signs are alternate, you can see minus, plus and so on, and the number will be the same as the order. If I am taking del square, then the denominator will be 2. If I am taking del cube, the denominator will be 3. Del raised to 4, denominator will be 4. So this is the formula for dy by dx at x is equal to x0. Similarly, we have to find d square y by dx square. So how we can find that? See, if I want to find d square y by dx square, so it can be found by this d by dp of dy by dp into dp by dx using chain rule. Okay, so we have to take the derivative of dy by dp. So what will be the derivative? See, dp by dx, we know that dp by dx is 1 upon h. So 1 upon h into 1 upon h will be 1 upon h square. And by simplifying this, you will get the term like this. First of all, the derivative of del y0 will be 0, so del square y0 plus 6p minus 6 upon 6 into del cube y0 and so on. That can be written as 1 upon h square del square y0 minus del cube y0, because 6 will be common. Okay, this is the formula for d square y by dx square at x is equal to x0. See, for x is equal to x0, p will be 0. Okay, so by replacing p is equal to 0, it can be written like this: del square y0 minus del cube y0 plus, see, you have to remember these steps and formulas. Okay, so this is the formula to find y double dash or d square y by dx square at x is equal to x0. Instead of 1 upon h, we are using 1 upon h square. Then we have to start from the second order derivative, second order difference, del square y0, then alternate sign minus del cube y0 plus 11 by 12 del h to 4 y0 and so on. So in this way, this is the formula that can be found with the help of Newton's forward interpolation. And when we have to apply this, if the value of x is near the starting point, then we have to apply forward interpolation. And if the value of x is near the ending point of the x, then we have to apply backward interpolation formula. Okay. Similarly, you can also derive the same formula for Newton's backward interpolation. But what will be the difference? Instead of y0, we have to use yn. Okay. So first of all, let us write the formula for Newton's backward. Yn plus p nabla yn plus p into p plus 1 upon 2 factorial. Nabla square yn p into p plus 1 into p plus 2. Okay. If you will find dy by dx at x is equal to xn, then you can write like this: 1 upon h nabla yn plus nabla square yn by 2 plus nabla cube yn by 3 plus nabla raised to 4 yn by 4 and so on. Similarly, if I want to find d square y by dx square at x is equal to xn, then it can be written as 1 upon h square. See here, instead of y0 we are writing yn, instead of del we are writing nabla, and instead of alternate sign we are taking plus sign. See, you can derive this, but there is no need to remember the proof. You can directly remember the formula. Okay. Here we have to start from second order difference, so nabla square yn plus nabla cube yn plus 11 by 12 into nabla raised to 4 yn and so on. So these are the two formulas that can be derived with the help of Newton's backward interpolation formula. Okay, now let us take one example on the basis of this that is asked in GTU exam. Okay. Okay, let us solve a numerical on the basis of this. See, this is the given data. The values of x and y are given. Nothing is given except y dash. See, what is given? What is the statement? Find y dash at x is equal to 1.1. Nothing is written. They haven't written any interpolation or any differentiation formula. So you have to identify that which formula we have to apply. See, which formula we can apply here. First of all, you have to check for the equal intervals and unequal intervals. See which interval is that. You can see here the difference in the values of x is 0.1. So the value of h is 0.1 and that is fixed. So we can apply the Newton's forward or backward. Okay. Now we can apply forward or backward. Again, that is a question mark. See, here you can see the value of x. What is the value of x here? The value of x is 1.1. It is near the starting value. So we have to apply Newton's forward interpolation formula. So first of all, which is our first step? We have to apply the numerical differentiation formula for Newton's forward interpolation, but before that we have to make a difference table. So let us make the difference table for this numerical. How many values are there? See, 7 values are there, so there will be 6 differences. See, let us write that x, then y, del square, del cube, del raised to 4, del raised to 5 and del raised to 6. Lines are not straight, okay. No need to worry about that. See, first of all, in the calci you have to fix a decimal place as 3 because in the values of y there are 3 decimal places. Okay, so the decimal places should be 3 in the calci. Okay. See, it is very much important to do this, otherwise there will be mistake. Then let us write the values of y: 7.989, 8.403, 8.781, 9.129, 9.451, 9.750 and 10.031. Now we have to write the difference values. First difference, what is the first difference? 8.403 minus 7.989, the answer is 0.414, then 0.378, 0.348, 0.322, 0.299 and 0.281. Again find the difference right here. Minus 0.036, minus 0.030, minus 0.026, 0.023, minus 0.018. Okay, then again take the difference. In the third difference it will be 0.006, 0.004, okay, again 0.004, and the last will be 0.005. Fine. Minus 0.002, this will be 0. Okay, and minus 0.001. Fine. Again here 0.002 and minus 0.001, and the last value will be minus 0.003. Okay, so this is the forward difference table. Okay. Now we remember the formula to find y dash, okay, at x is equal to 1.1. See, we are having the formula to find the value of dy by dx at x is equal to x0. But here we have to consider, see, remember most of the students are doing mistake here. We have to consider this value as x0. Okay, we have to consider this value as x0. So this will be my y0. We have to take the second value, right? This will be my del y0, del square y0. See, you have to take the second value of the table, right? Del cube y0, then again del raised to 4 y0 and del raised to 5 y0. And then you have to place all of these values in the formula to find the answer. So let us place all of that values. First of all, let me write the formula for y dash. See, it can be written as 1 upon h del y0, then minus is there, minus del square y0 by 2 plus del cube y0 by 3 minus del raised to 4 y0 by 4 plus del raised to 5 y0 by 5. Okay, by placing all of these values. What is the value of h? H is equal to 0.1, so 1 upon 0.1 del y0. See, here we have to take 0.378, we have to take the second value of the table, right? Minus 1 by 2 into minus 0.03, okay, plus 0.004 upon 3 minus 1 upon 4 into 0 plus 1 by 5 into minus 0.001. See, by solving this you can get the answer, and my answer will be 3.941 up to 3 decimal places. Okay, so in this way you can find the answer in the numerical. What if instead of 1.1 any another value is given, or 1.0 is given? Then we have to take the first value of the table. Okay, we have to take the first value of the table. Okay, and what about if y double dash is asked? Then you have to apply the formula of y double dash. Okay, see, in this way you can solve the numericals on the basis of numerical differentiation. In the next lecture we will solve some more numerical on the basis of this method. Okay, till then have a good day. Bye bye.